Now we're going to graph the secant and cosecant functions. And the way to remember these graphs is kind of similar to what we did with tangent and cotangent. We're going to rely on what we know about sine and cosine. And so let's start with secant here up at the top. Now remember, secant x is equal to 1 over the cosine. So what I'm going to do is I'm starting with a grid with the quadrantal angles already marked and a 1 and -1 on the vertical axis. I'm going to lightly in pencil sketch a cosine graph. So I start at 1 on the vertical axis, pi over 2, down to -1, 3 pi over 2, 2 pi, 5 pi over 2, 3 pi, and in the negative direction. So this is cosine. Now what I want to think about doing is I want to take the reciprocal of cosine. And so what's going to happen is there are going to be several values of x where secant is not defined. In fact, whenever cosine is 0, I'll be trying to take 1 over 0, something that's undefined, and the graph will have a vertical asymptote very similar to the kinds of asymptotes that we see with tangent and cotangent. So wherever cosine is 0, secant is going to have a vertical asymptote. Here, pi over 2, 3 pi over 2, 5 pi over 2. And that's because I'm trying to divide by 0. That's what brings about this vertical asymptote situation. Now, there are some points where the graphs of secant and cosine coincide. Wherever cosine is equal to 1, 1 over 1 will still be 1. So when cosine is 1, secant is 1. So where cosine is 1, secant is 1. Where cosine is 1, secant is 1. So here. And wherever cosine is -1, secant is also -1, because 1 over -1 is -1. So these points at the bottom of the wave are also on the graph of secant. But now here's where the graphs differ. If I think of my x value increasing from 0 to pi over 2, from 0 to 90 degrees, cosine takes the value 1 and actually gets smaller and smaller, approaches 0. But when you take 1 over that, when you take 1 over something that's getting smaller and smaller, you're actually going to get larger and larger values. So what happens with secant is, as we move to the right of x equals 0 toward pi over 2, the values of secant blow up and get larger and larger. And to the left, similar thing occurs. 1 over a positive number is still positive, but near the vertical asymptotes, the values of secant blow up. Between pi over 2 and pi, a similar thing occurs, but in a negative direction, because between pi over 2 and 3 pi over 2, cosine is negative, so 1 over a negative is still negative. The values of secant are negative. So for instance, from pi to 3 pi over 2, as cosine changes from -1 and approaches 0, the reciprocal of that will start out at -1 and blow up in a negative direction. And between pi over 2 and pi, we blow up in a negative direction. And this pattern will repeat itself over and over again. And so wherever there's a hill of cosine above the x-axis, we get this sort of U upward shape of secant. Wherever there's a valley of cosine below the x-axis, we get this sort of overturned U shape approaching those vertical asymptotes. So I'm actually going to remove the cosine graph from my picture. I wouldn't mind if you ever left it on a graph that you drew. I think I'll always use it to help me sketch this picture, but really the graph of secant is just the blue portion that I've drawn. The period of secant is 2 pi, just like cosine. Sometimes students think the period should be pi because it seems like we just repeat one of these U shapes over and over. But if we take one of the U shapes by itself and repeat that, we just get U, 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 U. We never get the overturned U. We really need one of each and repeat that pattern of an upturn and an upside down U, one after another. Repeat that pattern over and over to get the full secant graph. That's why the period is really 2 pi. We need one of each of those. The domain of secant is the same as the domain of tangent. Which is messy. Same as domain of tangent. The range of secant is kind of interesting because it's kind of the opposite of the range of cosine in a way. We take large values of y, very negative values of y, and we have this gap in between. We would say the range is from negative infinity to negative 1, square bracket, union, square bracket 1 to infinity. Secant, again, has period 2 pi, and it's an even function, just like cosine. You do not get the same graph if you rotate it 180, like you do for an odd function, but we do have this symmetry around the y-axis. If we fold along the y-axis, the two halves come together. Now cosecant. I think from what I said, you should be able to guess what the graph of cosecant x would look like. Cosecant is 1 over sine, so there's going to be a similar relationship between cosecant and secant is what we see between secant and cosine. With cosecant, I would lightly draw a graph of a sine wave, sine function. 1 at pi over 2, 0 at pi, negative 1 at 3 pi over 2, 0 at 2 pi, etc. Negative 1 at negative pi over 2, 0 at negative pi, like so. And then I'm going to do the same type of thing I did with secant. Wherever sine is 0, 1 over sine will have a vertical asymptote. And there's a vertical asymptote on the y-axis also, right? And here at pi. Wherever cosecant is 1, wherever sine is 1, cosecant will be 1. Wherever sine is negative 1, cosecant will be negative 1. And then we have that same kind of U shape, either pointing up or down, with the graph approaching the vertical asymptotes on each side, because we're taking those reciprocals. The reciprocals of quantities approaching 0 will blow up, either in a positive or in a negative way, depending on whether we're working with positive or negative quantities. And so the graph of cosecant and secant, they look very similar. And that should seem reasonable since the graph of sine and cosine are similar, but they're also different in the same ways that sine and cosine are different. The domain of cosecant is the same as the domain of cotangent. And that should seem reasonable because cotangent has sine x in the denominator. That's what causes the trouble. Just like secant and tangent both have cosine in the denominator. So secant and tangent have vertical asymptotes in the same place. Cosecant and cotangent have vertical asymptotes in the same place. The range of cosecant is the same as the range of secant. We can see that. Cosecant is an odd function, not an even function. We cannot fold along the y-axis and have the two halves come together, but if we turn the cosecant graph upside down, we get exactly the same picture, that odd function property. And so that's the end of our 6 graphs of the trig functions. I hope you guys can see that the way we think of secant, cosecant, or the way I sketch these graphs is I rely on what I know about cosine and sine. Similar to the way I rely on what I know about sine and cosine to get the graphs of tangent and cotangent.